Welcome to the DIY Honda Garage channel. The DTC P154B indicates an abnormal condition related to the battery sensor's characteristics in the Honda CRV models from 2017 to 2022. The battery sensor plays a crucial role in monitoring various parameters related to the battery, including its current state, temperature, and charge level. It is typically located near the vehicle's 12-volt battery, either attached directly to the battery or mounted nearby for ease of access during diagnostics. This sensor is essential for the Powertrain Control Module, PCM, which utilizes the information to manage engine performance and ensure optimal fuel efficiency. Understanding the symptoms, causes, and troubleshooting steps for a DTC like P154B is essential for effectively resolving the issue. In this presentation, we'll cover a detailed diagnosis process focused on this specific error code, ensuring a comprehensive approach to vehicle repair. DTC P154B refers to a situation where the battery sensor exhibits abnormal characteristics. This sensor is critical in providing the PCM with accurate information regarding the battery's health and performance metrics. Located adjacent to the 12-volt battery, it monitors essential parameters like temperature and current flow. Any discrepancies in the sensor's reporting can lead to erroneous data being fed to the PCM, affecting engine management and vehicle performance. It is essential that the battery sensor functions optimally, as it impacts not just engine performance, but also the efficiency of electronic systems. Diagnosing issues related to this code requires careful examination of the sensor's output and the vehicle's battery conditions. Several potential causes could lead to the emergence of DTC P154B. A common reason is a faulty battery sensor that provides inaccurate readings to the PCM. Poor electrical connections can also trigger this DTC. Corrosion or frayed wires at the sensor or PCM may interrupt the signal. Temperature discrepancies between the sensor's readings and actual measurements can indicate malfunctioning parts. Specifically, if the estimated battery temperature diverges significantly from actual readings, this could suggest sensor failure. Understanding these causes is crucial for implementing effective diagnostic strategies and ensuring a thorough inspection process while troubleshooting. When DTC P154B is present, drivers may notice various symptoms affecting vehicle operation. Engine performance may deteriorate as the PCM receives incorrect data from the battery sensor, leading to issues such as rough idling or unexpected power loss. Additionally, the vehicle may display battery-related warning messages on the dashboard, alerting the driver to a potential fault. Erratic functions of electronic components, such as the audio system or climate control, can also arise, further indicating that the vehicle is somewhat compromised. Pay close attention to these symptoms during the diagnosis process, as they can guide the technician in identifying the root cause of the DTC. The first step in troubleshooting DTC P154B is conducting a DTC check. Start by turning the vehicle to the on mode without starting the engine. This allows the vehicle's onboard diagnostic system to prepare for a scan. Utilize the Honda Diagnostic System, HDS, to check for any confirmed or pending DTCs. It is crucial to identify if there are other fault codes such as P0112 and/or P0113, as these codes can point to issues related to the intake air temperature IAT sensor, which may compound the problems with the battery sensor. If such codes are present, it's imperative to resolve them according to their respective troubleshooting procedures before proceeding further with the DTC P154B diagnostics. In the second troubleshooting step for DTC P154B, you will perform a 12-volt battery temperature check. Open the hood to access the battery and carefully measure the temperature around the battery sensor using a thermometer. It's important to record this measurement accurately, as discrepancies can indicate sensor failure. Next, start the engine and allow it to idle for approximately 10 seconds, which lets the system stabilize. After idling, use the HDS to check the estimated battery temperature parameter. If the estimated battery temperature differs from the thermometer reading by 41 degrees Fahrenheit, 23 degrees Celsius, or more, this suggests that the battery sensor may be faulty, and replacement is warranted. The third step in troubleshooting DTC P154B involves performing a battery sensor signal check. Start by turning the vehicle to the off lock mode, then switch back to the on mode. This action resets the vehicle's electronic systems, preparing them for accurate testing. Use the HDS to assess various parameters related to the battery sensor, particularly focusing on the battery current. Check if the current condition of the battery sensor shows more than 0 amperes, which is the expected threshold for proper functionality. If these current readings align with the predetermined thresholds, the battery sensor is likely functioning correctly. However, if not, replacement will be necessary. Additionally, if the system seems to operate normally, but the DTC appeared intermittently, inspect for loose connections or poor terminal contacts that could be causing the observed discrepancies. After completing the troubleshooting steps for DTC P154B and conducting necessary repairs, it's crucial to perform final verification. Begin this process by ensuring that any recorded DTCs have been cleared from the system. This allows you to monitor if the issue reoccurs. Follow this by conducting a test drive to observe the vehicle's performance under various conditions. Ensure that the engine runs smoothly without triggering any further error codes. Only after confirming that everything operates as intended should you consider the repair complete. This final check is essential to provide confidence to both the technician and the vehicle owner that the problem has been fully resolved, helping to avoid any recurrence of the DTC. Preventive maintenance is fundamental in avoiding issues like DTC P154B from occurring in the future. Regularly inspect the 12-volt battery and its associated components to monitor for signs of wear, corrosion, or damage. Cleaning battery terminals and ensuring secure connections helps prevent poor electrical contact, which can lead to erratic sensor readings. Additionally, checking the battery's fluid levels and voltage during routine maintenance can reveal potential problems before they escalate. Keeping the vehicle's electrical system healthy minimizes the risk of DTCs related to battery performance, ensuring reliable operation. Adopting these practices creates a culture of preventative care, extending the lifespan of the battery and associated components. In conclusion, DTC P154B signifies an abnormality detected in the battery sensor, which can significantly impact vehicle performance. Properly understanding this diagnosis is foundational for effective troubleshooting. We've outlined a step-by-step approach that includes checking the DTCs, measuring battery temperature, and assessing the signal from the battery sensor. Each of these steps helps ensure comprehensive diagnostics, keeping in mind potential issues such as poor electrical connections or faulty sensor behavior. Moreover, regular preventive maintenance is critical in avoiding these types of issues altogether. By following the guidelines provided in this presentation, technicians can help maintain optimal vehicle performance and longevity, ultimately benefiting both the vehicle and its owner. Please like and subscribe to the channel. See you next time.